Hi folks, we are back with the second video for the Unit 1 Day 7 lesson. And here I'm going to continue looking at how to graph points in R3, so in a three-dimensional space. As you can see, I've kind of set up for the next two. Here I've drawn out my axis and I've got these points S and T that I'm going to plot. If you guys feel like you're at the point where you can attempt this on your own, it might be a good idea to try that and then kind of watch the video and see if that worked out, see if you were able to do that. I'm going to go through a little bit faster than last time with my steps. So remember that the first point, we need to get 8 points on the vertices, 8 points as the vertices of that rectangular prism. So if you looked at any box shaped object you have in your house, there's going to be 8 corners, and those are the points that we really want to plot. We're always going to have the origin as one of my vertices. Now I'm going to keep up the color coding again because I think that could be helpful, going back to that earlier slide. And I'm going to plot the x coordinate in red. So here, just to maybe underline up here, I've got an x coordinate of -2. So I'm going to go into the negative direction, which we all had all positive ones in the first slide. So I'm going to go to the negative direction for x and put a red dot at the 2. Then my y values were green. So I'm going to go 1, 2, 3 in the y direction and put a dot there. And my z value is -1, so I'm going to go 1 down in the negative z direction and put a dot there. So you can see this is sort of hard to point out on a flat page, but we're going to kind of get like that rear lower, not quadrant, but section, 1/8 of this three-dimensional space where we've got a negative x, a positive y, and a negative z. Now usually if we're looking at this in class, one of the helpful things you can do is to take like a little bit of plasticine or Play-Doh or something and kind of get 6 straws and stick it in the x, y, and z axis to kind of build this, and it can help to visualize that a little bit. So from there, I'm going to find the next 3 points, which are going to be the points on those x, y, yz, and xz planes. So I'm going to start with the yz because that's like the nice kind of perpendicular one. So the most important thing here is that all pencil lines must be parallel to one of the 3 axes. If you go drawing a line like that where it's not parallel to an axis, you're gonna go so far wrong and it's not gonna work out. So only draw your lines parallel to an axis. That's a #1 rule for this. So I'm going to take this blue point and draw a line that goes parallel to the y axis like that. Then I'm going to take up the green point and draw a line that goes parallel to the z axis where that blue dot was, like that. And where those 2 lines intersect, that's going to give me another point, one of those 3 points that are on the XY, YZ, and XZ planes. I'm going to go through and do the same thing for the other pairs. So this one came from the green and the blue, and I got to that dot. Now I'm going to, can get a little bit messy with all the kind of extra pencil marks. Some people like to erase kind of as they go. Some people wait till the end. Either's fine. Now I'm going to look at the green and the red. So I'm going to draw a line through the green parallel to the axis that has the red. And then I'll draw, oh, that doesn't look very parallel. That better? That's a bit better. And then I'll take the red point and draw a line parallel to the axis that has the green point on it. And where those 2 lines, those 2 pencil lines intersect, I'm going to put a vertex. Okay? I probably shouldn't have erased these quite so soon. Pencil those guys back in. Then I'm going to do the blue and red as a pair. So now I'm going to take the blue dot and draw a line parallel to the axis that has the red dot on it. And then take the red dot and draw a line parallel to the axis that has the blue dot. And this one kind of looks like it wound up on the y-axis, but I'm just going to draw a little bit above to make it stand out, because maybe that y-axis is in front of our point there. So now I have these three new points. So I have my original origin, I have the 3 points on the axis, and then 3 points on those special planes. I'm going to fill this in by creating these dotted lines to kind of start building this rectangular prism. So I've got this green there going in the direction of the Y. I've got my blue z-axis, so I'll dot those in. Those ones are going to be smaller because it only goes -1. And then I have my red for my x-axis. And the last one is kind of the trickiest to get. And that's really the one where you're actually getting to that point P, or in this case, point S, that I'm going to have to take from each of those 3 points on the planes. I have to draw another line going out parallel to the axis that wasn't involved in the first place. And those will all connect at a point. So this point here came from the green dot and the blue dot. Now I need to draw a line from here parallel to the red, or the X. So I'm going to draw that up that way. And this one came from red and green, so I need to draw another line through this parallel to blue, or the Z. And then this one came from red and blue, so I need to draw another line parallel to the green. I'm kind of fudging it a little bit to make that distinctly above the y-axis so it's not obscured. So then I will put in the dotted lines to complete the sides of my rectangular prism. And that point there, that last point that you get by connecting the 3 lines coming out of those points on, on your points on the planes, this point here is my point S. So it's that point there that's -2, 3, -1. So that, let's smudge that. That point is the one that we're coming to. So a vector would draw from the origin to that point. But that's kind of hopefully gives you a bit of a perspective. You have to kind of force your perspective to see that in that third dimension. So it's actually kind of back and to the right and down from the origin. So last one for these. Again, I'm gonna try and speed this up a little bit. Starting at the origin, it's always one of my points. Now I'm going 3 in the positive x-axis, put a point there. Then I go -4 in the y-axis, so that's 1, 2, 3, 4, and put a point. And 2 in the z-axis, so it's going up 2 and put a point. Now I need to connect these to create my points that lie on the plane. So I'm going to do green and blue first, because they're the nice rectangles that go at right angles. So I get a point there, and then I might do green and red. So I need to draw parallel to the axes at all times. You're making parallelograms because if you've kind of drawn in art or in anything like that, drawn a rectangular prism, you'll know that you end up with parallelogram shapes. And then I'll do blue and red. So through the blue, I go parallel to the red axis, or the X, And through the red, I go parallel to the blue axis, or the Z. So I get a point, maybe line just below. And you do tend to get some kinds of sort of weird overlaps in these. So I'm going to highlight the lines that I'm keeping with each color. And then I will erase the rest. There will for sure be need for erasing kind of the extraneous notation and lines that you make while you're doing this process. So I'm just going over the ones that are actually the edges of my rectangular prism. Those ones I'm going to keep. The other ones will get erased. The stuff that goes beyond those points, or kind of any mistakes I make in graphing that. So I've got 7 out of the 8 corners, vertices of this rectangular prism. My last one, I need to extend from these 3 points that were on the X, Y, YZ, and XZ planes, extend another one. So this one came from blue and red. I'm going to extend another line parallel to the green, the Y-axis. This one came from red and green. I'll extend a line parallel to blue. And these should all meet at the same point, or very close to. That's another kind of way to check. This one came from blue and green. I'm going to extend a line parallel to the red, and you'll see that it goes through, or pretty close to goes through, that point there. So this is my point T. That last point is always the point that you're looking for. And then I'm just going to kind of brush this up, fill in the color-coded ones. And once you get that all set, if you were asked to draw the vector, so you might be asked to draw the vector OT from the origin to point T, you just simply connect that point that you made with the origin, draw a vector going kind of all the way diagonally through that box. It sometimes gets a bit obscured by the lines you've already drawn. Color can help there, and that would be vector OT. Sometimes you'll be asked for the vector, sometimes not. So moving along from drawing, here's one where it's drawn for you, which is probably a bit of a relief. So we've got this point, we've gone 4, and this is really not to scale. We've gone 4 in the X direction, 2 in the Y direction, and -6 in the Z direction. So the first thing is, can you state the coordinates of all of the other points? So we're going to do this on here. Can you give me the coordinates of all of the other points? And I'll start off with O, or the origin. We know that that's 0, 0, 0. So to get to this point P, we've gone 4 in the X, 2 in the Y, -6 in the Z. So let's try the ones that are just actually on the axis. This point A is going to be just 4 in the X. So it's gone the same distance along the X-axis as P has, because this didn't move any other. But it hasn't gone in the Z direction up and down, and it hasn't gone in the Y direction. So this would be 4, 0, 0. Any point, just like in R2, any point that's on the axis will have zeros for the other coordinates. Kind of similarly, point C, which is on the Y-axis, will have coordinate 0, and then it'll have the same Y value as point P, and it has no movement in the Z direction. And then G, which we could label on the Z-axis, same idea. It's just gone straight down. It hasn't gone along the X. It hasn't gone along the Y. So that'll be 0, 0, -6 for G. The next 3 points, we have to identify which axes that these are on, or which planes, pardon me. So D here, it's gone in the X direction and in the Z direction, but it hasn't moved in the Y direction. So it will have a 0 in the Y. So it has gone 4 in the X, it hasn't gone along the Y, but it went -6 in the Z. So that's 4, 0, -6. So if something lies on the XZ plane, it has an X and Z coordinate, but the Y coordinate is 0. Similarly for F here, it has gone in the Y direction, it's gone in the Z direction, but it hasn't come along the X axis. So its X value will be 0. Then its Y value will be 2, and its Z is -6. Lastly, B up here. So point B, it's gone in the X and the Y direction, but hasn't gone up and down. So its Z will be 0. Its X and Y are going to be directly above point P. So it'll be 4, 2, 0. Okay. The other thing asked me to draw in vector OP. So again, just taking a ruler, drawing a line from O to your point P, put an arrow on it and label it with the vector. That one's a little bit bigger than the box diagrams in the previous example that were a bit more squished in, so that's easier to see. So we've done that and we've done that, both on the diagram on the last page. Okay, so let's try and talk about the XZ plane. We want to come up with an equation for the XZ plane. So remember that the XZ plane, looking at these ones, that was where it didn't move along the Y. So point O, A, D, and G are all on that XZ plane. They kind of form this side of this rectangular prism. That flat side of the box lies on the XZ plane. So we can look at the points on there that are all in common. So O, which doesn't actually tell us much, A, which is 4, 0, 0, D, which is 4, 0, -6, and G, which is 0, 0, -6. And all of these points, and actually all points on the XZ plane, are going to have something in common. Hopefully you can spot it. These are not maybe the best examples, but if we look at this middle value, they all have a Y value of 0. So they are all going to be an X value, a 0, and a Z value, because you're moving the X and Z directions, but you're not going in the Y direction. So all points on the XZ plane will be of that form. So X and Z are any real number, and the equation of this plane is just Y equals 0. Now, we are going to get way deeper into equations of planes in Unit 3. But for now, you will be expected to find the equation of a plane only if it is parallel to one of the 3 special planes, the XY, the YZ, or the XZ planes. Last example here, let's give an equation for the plane that contains points G, D, P, and F. So that's from that previous diagram. I'm just going to write out those points. So G was 0, 0, -6. D was 4, 0, -6. P was 4, 2, -6. And F is 0, 2, -6. So what do these all have in common? So the X values are different, the Y values are different, the Z values are all the same. So it's not any kind of complicated calculations or anything. It's just writing out points that you know and seeing what do they have in common. So all points on the plane that contain those points. So on our diagram here, I'm gonna mess this up a little bit more. Let's maybe highlight this. So that would be this bottom face, the bottom side of that box. So the plane going through G, D, P, and F, this flat bottom of the box. They all have something in common, and that's all of the points are going to be of the form an X value, a Y value, and then -6. That -6 is a constant. So the equation of this plane simply is Z equals -6. So in this unit, this won't be true in unit 3, but for now, you guys will be expected to find the equation of planes only if the equation of a plane is recognizing one constant value. So the equations of the planes you might find are Y equals 3, or X equals 0, or Z equals -6, stuff like that. You list out the points you know on that plane and recognize which value, the X, Y, or Z, is a constant number. And that's it for day 7. I know this one was a long one, guys, but 2 more to go in unit 1.